Video 7 of our chemistry series. In this video, we will be going over redox reactions, also known as reduction oxidation reactions. So what are redox reactions? Redox reactions are reactions that involve an electron transfer between substances and compounds. Substances that gain electrons are reduced, and their charge ultimately decreases through the reaction. Substances that lose electrons in the reaction are oxidized, and their charges increase as a result of the reaction. This reduction and oxidation happens simultaneously during the reaction. Oxidation states are a vital concept in understanding redox reactions. They're influenced by electrons that are removed and added to compounds. Elements in compounds have positive and negative oxidation states, but singular elements in no state have an oxidation state of 0, except if they are specified ions in the equation. So let's look at an example. Here we have Cd plus NiO2 plus 2H2O reacts to create CdOH2 plus NiOH2. So here, let's break down the oxidation state of each of these elements. So first, let's look at Cd in its reactant form. In the reactant, Cd is a lone element and it doesn't have a specified charge and it's not a specified ion, so its oxidation state is 0. Now let's look at Ni and O2. So here, O2, oxygen has a charge of 2-, so the O will have an oxidation state of 2-. And since there are 2 oxygens creating an overall charge of 4-, and this compound has a balanced state, then this Ni has to have a charge of 4+, so its oxidation state is 4+. Here we have hydrogens, where we have 2 hydrogens to every 1 oxygen. Again, oxygen has a charge of 2-, which means each hydrogen has its charge of 1+. So the oxidation state of the oxygens in the reactants are 2-, and the hydrogen is 1+. Now let's look at the products. In the products, we know hydroxide, OH, has an overall charge of 1-. So here we have 2 hydroxides in each of these products, so there will be an overall charge of 2-. However, the hydroxides will have an oxidation state of 1-. This overall charge of 2- impacts the oxidation state of Cd and Ni, both of which are going to be 2+ to balance out the 2- charge of their respective hydroxides. So in the end, we have oxidation states of 0, 4+, 2-, 1+, 2+, 2+, and 1- for each of these hydroxides. Now let's look at how to balance a redox equation. There are 5 steps to balancing a redox equation. First, you must divide it into half reactions, which means you separate the reduction reaction and the oxidation reaction. Then you need to mass balance, where you will balance the amount of oxygens on one side by adding H2Os on the other. Then you will charge balance with electrons. You will electron balance between the reduction and the oxidation half reactions. And then you will combine the 2 reactions again and cancel reactants and products that are repeating, also known as spectator ions. So let's look at an example. Here we have Cr2O7 plus Cl- reacts to create Cr3 plus Cl2. In this redox reaction, Cr is being reduced as it went from an oxidation state of 7+, because O is 2-, and there are 7 oxygens, so this is a total charge of 14-. So Cr, with 2 Crs, each Cr has a charge of 7+, to an oxidation state of 3+. So Cr was reduced. Chlorine, Cl, was oxidized as it went from an oxidation state of 1-, noted by this negative, to an oxidation state of 0, as it is a lone element with no specified charge. So now we must divide these into half reactions. So the reduction reaction is Cr2O7 2- reacts to create Cr3+. And the oxidation reaction is 2Cl- reacts to create Cl2. These reactions are different from what you see here, as they were balanced. So the 2 was added to this chromium and the 2 was added to this chlorine. Now we must mass balance. So there are no oxygens involved in this oxidation reaction, so we don't have to mass balance there. but we do have to mass balance in the reduction reaction. Here you see that we have 7 oxygens in the reactants, but no oxygens in the products. So to replace those oxygens, we need to add 7 waters to the products, so 7 H2Os. So when we add 7 H2Os, we fill in those 7 oxygens that we're missing. However, we also add in 14 hydrogen ions, H plus ions. So in turn, in the reactants, we have to add in 14 H plus ions. This essentially helps us account for the missing oxygens that were lost during this reaction. And then now we have to charge balance. Charge balancing involves adding electrons to either side of the equation. So first, let's start with this reduction equation. Here in this reduction equation, after we mass balance, we have a total of 14 positive ions, and this compound is a 2- charge. So we have 14 minus 2, so the total charge of the reactants is plus 12. However, when you look at the products, the total charge of these products is going to be plus 6, as we have a neutral charge from the H2O, but 2 3+ ions. So 2 times 3 gives us a charge of plus 6. So we have a difference in charges between the reactants and the products here, as the reactants have a charge of plus 12 and the products have a charge of plus 6. So we must add 6 electrons on the reactants to balance out the charges, as now in this final half equation, in this final half reaction, the reactants have a charge of 6+ and the products have a charge of 6+. Now we would do the same with the oxidation half reaction. In the oxidation half reaction, we have a total charge of 2- in the reactants, as we have 2 negative chlorine ions, but a total charge of 0, a neutral charge, in the products. So since we have this charge difference, we need to add 2 electrons to the products, as now we have a total charge of 2- in the reactants and 2- in the products, thanks to the 2 electrons. Now we must electron balance. Electron balancing involves having the same amount of electrons in the reactants of one half reaction to the products of the other half reaction. So here we see that we have 6 electrons in the reactants of the reduction reaction, which means we need 6 electrons in the products of the oxidation reaction, as the electrons will eventually need to cancel out when we fully combine these 2 half reactions. So in order to get 6 electrons in the reactants, we must multiply all coefficients by 3. And when multiplying all coefficients by 3, we end with the equation 6Cl- reacts to create 6 electrons plus 3Cl2. And now we have our finalized 2 half reactions. So the last step of balancing this redox equation is to take our 2 finalized half reactions and combine them. So we take the reactants of this reduction equation and the reactants of the oxidation equation, and we combine them on one side, and we take the products of each respective equation and combine them on the other side. And now we have this full redox equation, but we have to cancel out spectator ions, which are ions that are not changing. They stay the same on both sides. Here we see that we have 6 electrons on the reactant side and 6 electrons on the product side. So these electrons can be canceled out, leaving us with a final balanced redox equation of 14H plus Cr2O7 2- plus 6Cl- reacting to create 7H2O plus 2Cr3 plus 3Cl2. So to summarize, oxidation is the loss of electrons and results in an increase in a compound's charge. Reduction is the gain of electrons and results in a decrease in a compound's charge. We use oxidation numbers to track electron movement in a redox reaction, and to balance redox reactions, we use half reactions, balance those separate half reactions using mass balancing, electron balancing, and charge balancing, and then we recombine those half reactions to gain a final balanced redox equation. Thank you, and I hope to see you in the next video.